Now we're going to move into what we call mutually exclusive, and obviously not mutually exclusive. Now, what is mutually exclusive? Mutually exclusive is if two events don't have anything in common. What I mean with that is, let's say I had two groups, so they have nothing in common. What type of question can I ask you guys? Looking at a classroom, I could come over and say, all right, probability of A is going to be, what's the probability that you're a guy, you're a male? And then we have probability of B, these are females. Right? You're either in probability in group A or group B. I could come and ask you, what's the probability I randomly choose a person and it's a male? That depends on how many males we have and depends on how many people we have in class. But you cannot be in both groups. You're either one or the other. That's what we called mutually exclusive. That means that they don't have anything in common. Now, let's say I come over and say, well, what is not mutually exclusive? What is it when person or something could be part of more than one group? Let's say I had a group A, and then I call this football. What's the probability that some people in my class are playing football? And then there's a group B, and let's call this soccer. What's the probability that people play soccer? Right? There are some people that play football only. They don't play soccer. But there's some other people that play soccer only, not football. However, there are some people that play both sports. So as long as we have a person or a member of the group that it's part of both groups, we call that not mutually exclusive. So once again, mutually mutually exclusive when we have both groups completely separated. They don't share anything. There's not a member in any of the groups that is part of both of them. You're either in one group or the other, not both. That is what we call mutually exclusive. Now, for not mutually exclusive, for not mutually exclusive, we have at least one member. Keep in mind, I'm not saying all of them. I said at least one member that is part of both groups. So as long as there could be one of them, as long as there is one of them that is part of both groups, it is not mutually exclusive. All right, how can we do this mathematically? Because one of them was group A, I call football called group A, and soccer group B. I see that in males and females. I also had group A and group B. So how do we do mathematically mutually exclusive? I'm just going to come and say, well, probability of A plus the probability of B is equal to probability of A or B. And then if you think about it, if I ask you guys, what's the probability of being a male? It depends on the class, how many males there are. What's the probability of being a female? If I happen to add them, probability of male plus the probability of female, if I happen to add them, I'm just going to have what's the probability of being a male or female. Technically, being a male or female, that's everybody in class. So if I add them, is equal to, so probability of A plus probability of B is equal to probability of A or B. Now, how do I calculate that for non-mutually exclusive? If I go probability of A plus the probability of B, let me not put an equal sign yet. I have the probability of A or B. Keep in mind that when I say or, A or B, I said you either play football or play soccer or play both. As long as you're part of one group, you're counted. Now, if I was just to let them equal each other, when I had probability of A plus probability of B, I have people that I counted twice because there were people that were playing football and there were playing people that were playing soccer. So there were people that were in group A and people that were in group B. So I counted some people twice. Therefore, probability of A plus probability of B is not equal to probability of A or B. Once again, the reason why is because when I counted them in the probability of A plus probability of B, since they're not mutually exclusive, that means there's a member that is in both groups. I counted that member or those members, I counted them twice. So if I was looking at the class, let's say I have some football players, but that some of them also play soccer, I counted those people twice. Therefore, probability of A plus probability of B is not equal to probability of A or B. All right, so let's take a look at question number 13. Now I have 2 over 5 plus 7 over 20. Probability of A plus probability of B. Now I don't know, so I'm going to put an equal sign and I'm going to put a question mark. I don't know if it's equal to 3 over 4. Right? If 2 over 5 plus 7 over 20 is equal to 3 over 4, in that case, it is mutually exclusive. If 2 over 5 plus 7 over 20, it is not equal to 3 over 4, then not mutually exclusive. Okay, so let's see. I have fractions. I see the denominator. So I ask myself, which one's the common denominator? 5, 20, and 4. I can make them all 20, right? I'm going to multiply my first fraction, top and bottom, by 4. So I have 8 over 20. My second fraction, just leave it over 7 over 20. Notice I want to have a common denominator. So I'm going to have everything with my denominator to be 20 because I said I can make them all 20. My last one, let me multiply top and bottom by 5. So I have 15 over 20. Now, is 8 over 20 plus 7 over 20, is it equal to 15 over 20? Right, we just add the two numbers on the top. Is 8 plus 7 equal to 15? Well, yes. In that case, these two are mutually exclusive. Now let's take a look at number 14. I'm going to go 9 over 20 plus 1 over 5. Is it equal to, I'm going to put a question mark, equal to 13 over 20. All right, let's take a look at our denominators. I have 20, 5, and 20. I have to make them all the same though. I'm just like, well, I can easily make them 20. The first one, I'm going to leave it alone. I have 9 over 20. The second one, the second fraction, I'm going to multiply top and bottom by 4. So I have 4 over 20. And the last one, I have 13 over 20. So now that I have all the common denominators, I'm just going to add the numbers on the top. Is 9 plus 4 equal to 13? Yes, 9 plus 4, it is equal to 13. Therefore, this is mutually exclusive. Let's take a look at question number 15. I'm just going to add probability of A plus probability of B. So I'm just going to go 9 over 20 plus 3 over 10 equals 33 over 50. Probability of A plus probability of B. I'm wondering, so I'm going to put a question mark on top of my equal sign. I'm wondering if it's probability of A or B. Okay, so common denominator. I can make them all 100. I'm going to multiply the first one by 5. I'm going to multiply the second one by 10. I'm going to multiply the last one by 2. I want to make my denominators the same. So I'm going to make them all 100. So the first fraction I said multiply top and bottom by 5. So that gives me 45 over 100. The second fraction I said I'm going to multiply top and bottom by 10. So that gives me 30 over 100. So I'm wondering, so if it's equal to, now the last question I want to multiply top and bottom by 2. That gives me 66 over 100. My denominators are all the same. In this case, 100. So now my question is 45 plus 30 equal to 66? Right, 45 plus 30, yeah, that's not equal to 66. Therefore, this is not mutually exclusive. Lastly, let's take a look at number 16. Probability of A is 3 over 10. Probability of 5 is 2 over. Probability of B is 2 over 5. I'm wondering if this is equal to 29 over 50. Probability of A plus probability of B, is it equal to probability of A or B? So I'm going to make them all 50. I'm going to multiply the first fraction. I'm going to multiply by 5. The second fraction, I'm going to multiply top and bottom by 10. The last fraction, I'm going to leave it alone. So I get 15 over 50 plus 20 over 50. Is it equal to 29 over 50? I want a common denominator. So 50 is all the way across. So I just worry about the top of the fraction. Is 15 plus 20 equals to 29? A question mark. Is 15 plus 20 equal to 29? Well, no, it's not. Therefore, this is not mutually exclusive. On your homework, you guys will have to choose, mutually exclusive or not mutually exclusive.